So I'd like to start learning a little bit about molecular structure. Now, molecular structure is actually really important because it can control a variety of different chemical behaviors. So when we're considering molecular structure, the first thing we need to do is literally draw the molecule. There's a couple of steps that we need to follow when we're trying to do this. The first is we're going to need to identify the type of bond that exists on the inside of your molecule. And there are three different types of bonds. We have nonpolar covalent bonds, polar covalent bonds, and ionic bonds. So to determine the difference between these types of bonds, you need to find the electronegativity numbers for the two elements involved in the bond and then subtract them. And based upon that difference, it'll tell you what type of bond that you have. If you have a difference between 0 and 0.3, your bond is going to be considered to be nonpolar covalent. Now what that means, the covalent part, means that you're going to be sharing the electrons. Nonpolar means that they're not going to be pulled to either one atom or the other, so they're shared equally. Polar covalent bonds, the difference in electronegativity will be between 0.3 and approximately 1.7. Now again, the covalent part means that they're going to be shared, but the polar means not equally. So the electrons are literally going to be pulled to one side of that bond, closer to the more electronegative atom. Ionic is between 1.7 and 4.0. And that is when the electrons are not shared at all. They're actually completely stolen from one substance and given to the other. They're always given to the more electronegative atom. So let's take a look at an example. Here's NaCl. So I went ahead and I looked up the electronegativity values for both sodium and chlorine. I found that sodium was 0.9, chlorine was about 3.2. I subtracted them, and I found the difference of 2.3. Now, when you're subtracting them, take the absolute value of the answer. This is not exactly, you don't have to worry about the signage here. So at 2.3 is the difference in my electronegativity. I can determine that there's an ionic bond between the Na and the Cl. Well, let's take a look at another example. How about CH4? Now, it doesn't really matter that there's 4 hydrogens there, but we do know that there's going to be bonds between carbon and hydrogen atoms. So I'm going to look up the number for carbon and hydrogen. I found carbon to be 2.5, hydrogen is 2.1, and when I subtract the difference between just those two numbers, I find that the difference is 0.4. This would give me a polar covalent bond. A couple other things that we need to remember as we're proceeding forward here is the number of valence electrons in each of the individual atoms in the main group. Now remember that the main group is everything except for the transition metals and then the rare earth elements down toward the bottom of the periodic table. So the first group that starts with hydrogen has 1 valence electron, beryllium's group 2, boron's group 3, carbon's group 4, nitrogen's group 5, oxygen group 6, fluorine's group, the halogens, 7, and helium's group, the noble gases, will have 8. Notice that there is one exception there. Helium only has 2, and that's just because he's so tiny he can't actually fit 8 electrons around the outside. Now, this also leads to the charges of the families on the periodic table. So just to try and quickly refresh your memory, that the alkali metals, the first group, positive 1, alkaline earth, positive 2, positive 3, skip, negative 3, negative 2, negative 1, zip. And then, of course, the transition metals on the inside have variable charges, and that's just because of their electronic structure around the outside. Most of the examples that we're going to be looking at for molecular structure will not include the transition metals. So let's start drawing some structures. We call these Lewis dot structures because we draw in the electrons like little dots. There's a couple rules that we need to follow. We want to first start by writing the chemical symbol for each element individually, and then drawing the valence electrons around the outside like dots. Now, every symbol is considered to have 4 sides, a top, a bottom, a left, and a right. And on each side, you can fit a maximum of 2 dots, for a total of 8 dots. So we start drawing. First, we start off with Na. Na, because it's an alkali metal, has one valence electron, so it gets 1 dot. Chlorine, because it's a halogen,